All right, in this next lesson, we're going to do 8.3, also from the 7th grade math book. And in this section, we're going to talk about cross sections. So what a cross section is you take a 3D shape. For example, we take this cone, and we take a two-dimensional plane, like a sheet of paper is almost a plane. And technically, this is a rectangular prism because it has some thickness there on the end of it. However, I'm going to treat this as if it's a flat surface with literally no thickness. It is a plane figure, P-L-A-N-E, not like an airplane, geometric plane. And we would take this shape and slice through one of our 3D shapes. So notice if I have a rectangular prism and I take this plane figure and I slice through horizontally, totally flat, it's going to intersect, let me see, my sheet of paper with a specific shape. And what we're going to do is we're going to identify these shapes. So I'll model a couple of them with this pretty sweet tool. Say we're going to do we'll do a prism, we'll do a rectangular prism. So I'm going to change to prism here, and I'm going to get lateral faces. We're going to have a total of four sides that is a prism. So we'll have a square on the bottom that is a prism straight up. I think it's up, let's see. Yeah, so the base of a square on the bottom, it's a prism that goes straight up. And we're going to take this red shape and we're going to slice through our shape. So notice if I have my plane figure straight vertical, straight up and down, and I go like diagonally through this shape. In fact, let's go like 45-degree angle almost. Straight through. I'm always making a rectangle. Maybe the rectangle is a little skinnier than some other times. Maybe it's a little thicker. But no matter what, it's always a rectangle. And I can rotate this around. I can rotate my plane around. And I'm still only always getting a rectangle, regardless of where I move this, because it's vertical. However, what if I tilt my plane figure at an angle and I move this thing around? So I'm still getting a rectangle, aren't I? But what if I tilt it even some more? Eventually, if I slice the corner of this thing off, so I take this plane figure and I go through it diagonally, that's going to make a triangle. So we should see right here, I have my cross section here is a triangle, and we can move it, and at some point it's going to be like, what is that, 5 sides? So it's like a diamond ring pentagon here. And here we even have a hexagon for a second. So it's possible to even have 6 sides. So you can see in my coordinate plane here the actual shape that this is made. So what you're going to do in this section is we're going to be looking at 3D cross sections, and we're going to decide what shape are these cross sections. So if I take my plane figure and go through a square pyramid, and I take it horizontally and slice it straight through, I'm going to get a square. And it doesn't matter how, whoops, not there. Where's my up and down? Here we are. It doesn't matter if I slice higher or lower. It's still a square. It just might be larger or smaller. And then let's go ahead and rotate this so it's a vertical slice. And there we go. That looks like it's vertical. So my shape is getting cut here vertically. This is kind of hard to work with. There we go. So here we see our slice is actually a trapezoid. If I slice through this square pyramid vertically straight down, I'm going to make this trapezoid, which would be from the side to the bottom to the other side, and then straight across through somewhere in the middle there. And we would be making a trapezoid. It's also possible that we have a triangle with a square pyramid. So here's our triangle. So I'm taking it and slicing. I know it's kind of hard to visualize here, but I'm slicing my plane figure maybe straight up through where my note card's crossing here and going straight up through this shape. In a perfect world, I'd have like Jello 3D shapes and I could model this, but I don't think that really exists. So a cylinder, we can have a rectangle. If it's vertical, no matter where I slice this, I'm always going to have a rectangle. However, I could also have a circle if I slice horizontally on a cylinder. And we could even have like this sort of partial circle, or even like curved, slanted, almost a rectangle, but not quite shape. So the way we describe these are probably just using the word like semicircle or partial circle. You are going to have one that is a semicircle or partial semi-oval. Is going to kind of look like this in your book. So what we're going to do is we'll just go through this. We'll go through these slides. Anytime you see a blue text box, or make sure you're typing into the box. And I'm going to literally give you all the stuff you should be typing here. So if you're watching this video, this should be pretty simple. So let's talk about cross sections. A cross section of a right rectangular prism. And here, this isn't a prism. Let me see. I don't know why it says rectangular prism. That's not a prism, and these aren't prisms either. Anyway, an intersection is a point or a set of points common to two or more geometric figures. So an intersection is usually where two things cross each other. It's usually two-dimensional, and they intersect at a one-dimensional point, one specific spot in the universe. So this two-dimensional line and this two-dimensional line cross right here. However, when we do 3 dimensions, we're going to take a 3D shape, 3D shape, and we're going to take a two-dimensional plane and slice through that. So a cross-section is the intersection of a 3-dimensional figure and a plane. Imagine a plane slicing through the pyramid here, or through the cone, or through the prism. So we have a pyramid here. I kind of already showed you a rectangular pyramid or a square pyramid. Now we can look at this cone here. We have a plane horizontally slicing through, and this is what all our cross sections are going to look like. There's going to be a yellow 3D shape that's kind of drawn out as well as you can, and then this blue or greenish color plane figure that slices through it. And then this black is the intersection of our 3D shape and the exterior of our the outside of our intersection. So from our 3D shape and our plane figure. So with this cone, we're intersecting what looks like an oval at this slanted view, but if it's a cone and you look straight down the cone and our plane figure goes through, maybe like right here, it's a perfect circle. Unless that is tilted, then it would not be a circle. Then it would be an ellipse or an oval. This one here, we have a triangular prism, and our plane figure is coming straight down the middle. So it's going to show actually the same shape as our base of that triangular prism. So we'd have a triangle as our cross section there. For the next slide, we're going to end up having to type on this one. So describe each cross section of the right rectangular prism with the name of its shape. So that's all we have to do, is we're just going to type in one or maybe a couple words to describe what shape did we make. For part A, we have a rectangular prism, and our plane figure is like starting here and goes down into this shape, so that just this little corner here is sticking out. And what shape do we see? Well, we see there's one side, there's one side, there's one side. So it's a 3-sided shape. So that there is just the triangles. Go ahead and type in the word triangle here. I'm not going to do all the typing. I'm going to let you handle all that. For part B here, we have another right rectangular prism with all 90 degrees and whatnot. We have a plane figure that's coming straight down or slicing straight through flat. The angle of this plane figure is parallel to the base and the height of this rectangular prism, so it goes straight through and makes a perfect rectangle for B. Next one, we're going to do these two. We have to describe each cross section, same directions. For part C, we have a rectangular prism, and this plane is actually coming through diagonally. And it kind of looks at this like it's diagonally, but also kind of slanted. I want to model this on this, let's see, I want to do that on here. So I can flatten it out. It's kind of annoying. X, Y, Z. There we go. Goodness, it's tricky. So we have, it's going to be slightly angled, and let me see if I can get it perfect. So angled there, a little bit angled here, and here's our shape. Notice that I do not have a right angle right here. This is an acute angle. It's a little less than 90. So is this one. If it was 90, it'd be a little more, it'd be more like here. However, this is not 90-degree angles. This here is a little less than 90. This is a little less than 90. Those are acute. And then these two angles are actually obtuse. They're larger than 90. So this, if you originally thought, oh, maybe it's a rectangle or maybe it's a square, that's not going to be perfect. But a perfect answer for that would be it is a parallelogram, because if we were to look at these and calculate the slope of these two lines, these red line segments would be parallel. And I'll keep it red and I'll just label it with two little marks. These red ones, these vertical ones, are also parallel, but they're not parallel with the single mark ones. So they're the two ones that are marked with one little arrow mark are parallel, and these two are parallel with each other. So if we have opposite sides that are parallel, if we have two sets of those, then that would be a parallelogram. So we have a parallelogram for part C. For part D, it looks like it is straight vertical up and down. Remember, if it was like slanted and tilted a little bit, like part C, that wouldn't be a rectangle. However, it looks like part D is going to be a rectangle, or maybe you even think it's a square, but I don't think they gave us any dimensions. So probably best to say it's a rectangle, even though it might technically still be a square. No matter what, it is a rectangle. So we're going to call D a rectangle. Because all squares are rectangles. Rectangle just means 90 degrees, 90 degrees, 90 degrees, 90 degrees. That's it. So looks like we have that. We're not going to call it a square because I don't know what these measures are. Next one. We have a pyramid. We have a square pyramid. And we've actually kind of already done this one using the interactive tool a little bit ago. The shape of a base. So in a right rectangular pyramid with a non-square base. So we have a rectangle as a base. Here's a rectangle. And it comes up to a point. It's kind of a weird pyramid. We don't really see very many of those. But it's a rectangle base that's not a square. We need to talk about what are these shapes. So is the shape of the base, oh my goodness, the shape of the base is a rectangle. The shape of each side, all the sides on this thing are triangles. Is a triangle. What is a triangle? All right. B, is it possible for a cross section of the pyramid to have each of these shapes? Is it possible for it to have a square? Well, let's think about it. If this was a perfect square pyramid, a horizontal one would be a perfect square. However, if we've got a rectangle base, this is kind of hard to visualize. If we've got a rectangle base and our point that all the sides come up to, your top of your pyramid, we'll say is right here, would it be possible to have all those points come up to a single point up here, but also angle your cross section so that it makes a perfect square. Because if I go just flat, I'm going to get a rectangle that's actually the same scale, it'd be a similar rectangle to this rectangle. So the question would be, would it be possible though to tilt that cross section to a point where it would make a square? I wish I had a better 3D model of it, but let me see if I can model it a little better. So I've got my rectangular base. They're all going to go up to this point. So it's kind of a goofy looking pyramid. Now let's see. If I'm trying to make a square, let's say I go through like this. Is it possible that that shape could have been a square? I think no matter what, I could move it around and angle it a little bit so that eventually I do get a square. So our first one square is going to be a yes. So this would be a yes. I want you to just type the word yes. Yet. Rectangle, definitely. We have a rectangle modeled here in the bottom left. So that's a yes. Triangle is done right here. Trapezoid, there it is. They took it and they went just straight down. So we've got a trapezoid. This is what it would look like. That's going to be a yes. Back to circle. Is there any spot that's even curved on this? You got to have curved spots to make a circle. So that in this case, it's going to be a no. Not on that one. So it'd be yes, 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 no, yes. Finally, let's answer these ones. What shape did we make here? Well, it looks like we have a cube with a plane figure coming off diagonally from point to point to point. Looks like we made a triangle. For number 2, let me get rid of all that. We have a cylinder. We're going straight down vertically. I think I showed that in the first model that I made earlier. We make a rectangle. And if we angled it and tilted that, I think it's still a rectangle to some point until it comes off of the circle base, and then it starts giving some weird curves and stuff. For number 3, we have a triangle prism vertically, and it's sliced just horizontally. So we have the shape with 3 sides. Go ahead and type that shape there. Number 4, we have a cone, and we are just slicing straight down. It's technically probably not a circle unless that's a perfect cone. I'm okay if you call this a semicircle, but more accurate is probably like a half ellipse. And that's how you spell it. And I like 1 minute. So on this last slide is a link to this cross-section tool, this interactive tool. So I would like you to just spend maybe the rest of class or a little bit of time, whatever your substitute says to do, and goof around with this tool. There's the link. Make sure you got all the blue boxes answered from this video and from the earlier video, and you are free to mark this as done.